Good morning, everyone. I'm Toby Woolffe. I'm from IBM, and I'm going to bring some of the concepts that Paco explained technically to life through the story of a case study we've worked with for a very large company, General Motors. But many of the ideas are things that can now be pushed out to actually any size company. So whilst many of the numbers in this slide deck that bring this story to life are absolutely enormous, many of the concepts are universal. The sort of things I'm talking about here are the idea that we're on the precipice of awareness of and adoption of internet-connected devices well beyond the smartphone. In my own personal experience, well, I've connected up my house heating system, so using my smartphone here, I can shut down my heating and save money, but before I get home, I can have it warm up the house. It's becoming fairly normal to do that now, but just who in the audience has such a similar system? And show your hand if you have a similar internet-connected device at home. Very, very low numbers of people. Well, I think you're going to find this kind of thing is taking off. The other experiments I'm doing at home, well, I'm into horses. I'm passionately into anything that moves, really. Vehicles is my work, and my home life is all around horses. And I've internet-connected 5 horses. And what I'm looking for is gathering data from these things to find out which ones are the fastest. But actually, in my case, I don't like falling off. I turned 50 recently, and falling off a horse is not good. So what I'm looking for is a horse that's pretty fast, but it goes around corners quite smoothly. So I'm looking at mapping data to look for a smooth line. Now, when we move back to my working life, vehicles. So General Motors are finding that when you start connecting a couple of hundred sensors to an internet connection, you're finding that you're going to generate around 400 megabytes a minute. It's a ridiculous amount of data. And that's part of the problem that triggered off this data warehouse project at General Motors. But the right-hand chart also talks to a 20% compound growth rate on the number of connected devices. So right now, most of us have cars, vehicles that are not internet connected. Maybe there is a connection for sat-nav. That's about as sophisticated as most people have right now. But the move headlong towards the connected car is really what's going to solve Madrid's traffic problem and help us find petrol stations when we need them in a hurry. And I'm glad we were running late today. Okay, so what's the problem? The problem, I've got little children. When I ask them when they want to know things, when they want information, generally speaking, they say, well, I want it now. And they reach for their smartphones. They're little kids, but they're pretty well connected. And they're not used to this paradigm. My world over the last 20 years of building out data warehouses that are primarily designed to deliver information at the speed at which the Earth moves around the sun, or the speed at which the seasons change, or the timing of maybe the moon shift. These are the timings that we've built businesses on, and some of these businesses are pretty big, and I don't think that's acceptable to people who want real-time information. When we put that in context of the vehicle, how interesting is it to know that you're approaching traffic in real time as opposed to the traffic that you've already hit being produced to you in a BI report? So we're experiencing this massive paradigm shift, and this is no longer good enough. These examples have served us well for a couple of thousand years, but they're pretty much irrelevant now. We have to do things in real time. So this story I'm going to run you through was published in the Wall Street Journal. It's public information, although I'm going to embellish it with some of the ways we've achieved these results. And this is a pretty high-profile project that General Motors invested $130 million in a new data center, and it was sponsored by a CEO. And the context here is that a CEO may be the sort of guy who renews their home boiler system, spends a bit of money on some sort of internet-connected device, and finds that actually it's quite useful. It's convenient, it saves money, and so on. And he's going to walk into the IT director's office in an industrial company he works in and says, look, I can control my home boiler using the smartphone. How come this £20 million machine that we make and sell to our customers, we can't control in the same way? Can you make it happen, please? So the IT directors and the CIOs are beginning to explore ways of actually bringing these concepts to life. And that's the kind of origin of many of the projects that end up being as big as this one. So lots of numbers coming at you now. General Motors has hired 1,500 software developers, and that's up from 0. So Tim Cox has had a lot of interviews to do. The reason for this is because they pretty much outsourced IT as non-core to General Motors' business. Their business was making cars. Why would they need IT for anything other than running an ERP system and maybe running a complex computer, CAD system, graphics design system? And look at the figure here, 70% of 10,000 staff to be focused on innovation. That's a great job title, isn't it? Now, what we're doing here is helping them move from a high number of distributed data centers around the world to really just 2 very big ones. And they're going to be pretty much running Hadoop platform on about half of those boxes. So these are the commodity pieces of hardware that Paco was describing. These are pretty much commodity off-the-shelf devices, but they're incredibly powerful. And when you wire them all together, you've got an enormous amount of compute capability at your disposal. The platform that they've put in from IBM to tie this together is a product we call Big Insights, and it's basically the management of a Hadoop cluster at extreme scale. So that's our bit of the delivery of this. In fact, quite a few more, but that's an important component that I think is justification for being here today. So let's look a little bit more about General Motors. Everyone thinks they know the company, but here's a few interesting facts. They were the sales leader in cars on this planet since 1931 to 2007. That's pretty impressive, but something obviously has knocked them off their position at the top. And that's summarized by the kind of problem where 212,000 people managed to let the competition get the better of them. Part of this was business problems such as recalls. So the company is very keen to make reliable, safe cars, but they have a recall issue right now. And this goes well extends the warranty that you get when you buy a car that may be for a year or 3 years into a legal liability that General Motors have to keep their customers safe pretty much in perpetuity. This big problem, the biggest high-profile one that's still running this year, has cost them $1.3 billion. It's not a joke, it's a serious amount of money, and people have died because of this. It was a fault where GM standardized on a lock. The thing you stick your key into to run the car had a fault. So this affected 28 million vehicles going back 7 years. And the problem is pretty simple. When you're driving down the road, if you have maybe a bunch of keys hanging off your keychain, if you hit a bump at a certain speed, it can actually turn the lock off while you're driving. And that has 3 serious consequences. The first is it shuts down the car electric system. And that means that the airbag isn't going to go off if you have an accident. Worse than that, actually, it shuts down the hydraulic system. So you've lost your power steering. You can still steer the car, but it's pretty difficult. And in the same way, the hydraulics that power the brakes means you've got about 2 squeezes of the brakes before you're into about 1/10 of the braking power that you really need to stop the car. So 13 people have died directly because of this fault, and General Motors have been fined, they've been in the press, it's not good for their reputation, and customers are extremely concerned. So this was actually the trigger to kick off a single view of the vehicle, a single view of the customer, and it's the perfect storm to build a data warehouse. So the business objectives that Randy Mott put up in public were to reduce operating expenses for their data warehousing operations by 25 to 30%. So this is a self-funded project. Deliver 10 times the measurable business value, and I can come through some detail of how they've achieved that, but the simple fact was that if you put all the data in one place, you save 80% of IT development time. 80% of IT development time is spent finding and organizing data. If it's all in one place, you've just saved an enormous amount of time. And that then contributes to doubling IT project capability because people aren't having to deal with the complexity of managing and moving data. It's all in one place. The integration of existing data warehouses, some of which were IBM technology like DB2, and some from our friends in the industry like Teradata, Oracle, and so on, meant that we actually had to create a platform to integrate all of these existing systems as well. So quite a challenge. And the abstract around this presentation was really how we've delivered this modernization with an architecture that's summarized on the right-hand side here, and I'll go through in a bit more detail in a minute, but it basically had to be high performance and continuously available. So many of the characteristics of Hadoop in terms of high availability and resilience, you know, if you've got 10,000 servers, you're going to get a dozen of these things catch fire per day. So how do you have a system that means that that cannot impact business? Remember the number of staff in the company was 212,000. Well, we've actually got 329,000 users on the system, so it goes well out into the supply chain. And I think that the next phase of this will extend out into the customers. When you buy a car, why don't you have an online access to see it going through the production line, see its service records, and then see predictive maintenance warnings coming through that? So we may end up a scenario where this thing goes to the next scale of adding some more zeros onto the user numbers for this data architecture. We achieved this through centralizing a data warehouse architecture, and there are a number of components of that. But the important bit here is to think about the data types. What do we put into this system? There's a list there on the bottom left, inventory control of parts. So from the 15,000 parts in each of the vehicles they make, there are hundreds, potentially thousands of suppliers too. So we had to take data from a large number of companies and put it in one place. Manufacturing equipment, well, things like robots spew out data to show that they're working, and most times that data is deleted at the end of the shift because there was apparently no need to keep it. But now we're keeping all of that data so we can track through assembly line faults that turn up later as warranty claims. We're also putting warranty and service data from dealers into it, and that begins to move from the very structured data into handwriting, PDFs, documents, little comments that are in free text. So we're now moving from very structured existing data that's disparate into the world of unstructured modern data. I've mentioned telemetry data. Now, we don't actually want to take a terabyte per car per year into the warehouse. So the idea of actually filtering out what's useful and either deleting it after we've moved it in there because we know it's no use, or building algorithms that mean only the data that is useful is actually going to be sent into the warehouse is still work in progress. And the portability of algorithms that typically start off through analysis of Hadoop data to find things that are useful, and then take that same algorithm and move it onto real-time analytics, and then ultimately move it into the car, is part of this journey we're going on with this customer to create the self-driving car. These things have to be smarter than they are now. Customer service and social media data means a lot to this company, because if your job was to recall 28 million vehicles from 157 countries, your problem is that the national databases that list who owns which car, well, it's all going to be pretty messy. It's not going to be in the same format, but you're also going to have to deal with people maybe twittering comments to say, well, I'm concerned, I've got a GM car, or I haven't had a letter about a recall, I wonder if my car is still safe for my family. So we're now beginning to think that you're going to have to proactively hunt for new data sources to fill in some of the gaps that aren't filled through your existing data collection processes. And that means that you've got this sort of history of traditional data sources, things that you're probably quite familiar with, but probably siloed within a large organization. But you're now going to have to add into it things like email, Twitter, and so on. You might have seen last week that IBM signed a deal with Twitter, quite a significant deal. And the concept here is that when you choose an IBM analytics product, one of the things that we're doing here is plugging in data sources to the back end of it. And one of the significant ones is that we plug it into Twitter. So if you believe that people are tweeting things about your company, such as propensity to buy a car, you're tweeting, hey, I'm thinking of buying a new car, or I've just had my 4th child, so I'm going to have to get an MPV, a whole lot of things out there, then companies like General Motors would be very interested to harvest that from Twitter to generate sales leads, to measure sentiment, and so on. And our strategy has been to initially to provide the tooling to support that, but now we're going to be embedding that data source into our product set. So that's a leap forward that brings IBM really into the front line of this kind of work of providing data, not just analytics tools. And the key to this thing, this is a vital bit of technology, has been the probabilistic matching engine that allows us to sort out from the complication of siloed data repositories the true meaning of, for example, a customer. Now, my born name is Tobias Wolfe, but hardly anyone uses that apart from the British government to collect taxes from me. So what I really would like is someone to recognize Toby Woolfe as my main identity and Tobias Wolfe as one sort of definition, if you like, of me. But it's the same person, and I don't like getting 2 emails from the same organization about the same thing. In simple terms. So this technology is used now to glue together the Twitter information, the Facebook profiles, your customer data from your existing systems or from your supplier systems, because it all has to be viewed in one place. And that engine is becoming more and more vital to tidy up and reduce the amount of data you're having to deal with. Coming back to General Motors, there were 3 things that these guys were looking for. First one was Hadoop. So there's a good number of Hadoop vendors out there, and the market is still, I think, pretty immature. There's not a great deal of difference between the vendors, but I suppose we were selected because we happen to fit best into their enterprise architecture, where things like security, granularity, integration into probabilistic matching engines, and so on began to mean something to them. So the middle box here in terms of data integration is really where we see the challenge over the next few years. How can you take new and emerging, brilliant new technology from us or from open source movements like Spark and actually build it into an enterprise architecture? And then on top of that, stick an advanced analytics platform on top. So people with different job roles can make use of the same technology platform and turn IT from being the provider of computing power into being the provider of business data. And that leap is quite a significant one. There are many other functional and non-functional requirements that begin to get turned into real requirements in this kind of architectural move. And IBM's position is that we're pretty exposed to all of them, actually. So it makes it a lot easier for us, because when we build architectures like this, we have to integrate our own products together. So many times the customer's problem is an end-to-end business process, such as the ones I can describe using this chart, which is our published connected vehicle reference architecture. It's a pretty versatile architecture, and this is pretty simplified. We've taken out a lot of the plumbing and bits and pieces of this to make it understandable. But the concept here was to look at the capabilities required to solve the business problem that I've just described. The first one, can we make the data protocols more efficient? Many of us sit in front of computers that cost thousands. We spend a lot of money on bandwidth inside or at home, when you're online. But still, you can see an HTTP page build in front of your eyes. This is a ridiculous environment. It's so slow, it's unbelievable. Very large files being moved and then building in front of you. So not many data warehousing guys have really thought about the need for it, making the data protocol itself more efficient. But this is a hot one for vehicles, because really HTTP is well, it's 6 times less efficient than the open source equivalent. So we're pushing open source pretty heavily, simply because if it's 6 times more efficient, we can get the information to the vehicle much, much faster. We can use less power to power smartphone devices. Internet-connected devices will run a lot longer on a battery if they're not spending the whole time polling. So in this architecture, starting off with the data protocol at number 1, we then look at real-time analytics. And this is an interesting place to put algorithms that filter data to save you having to store all the absolute junk, but also can provide a real-time alerting capability. So coming back to the car type analogy, it's not much use to know that you were doing 70 kilometers an hour yesterday. You need to know that in real time with a good degree of accuracy and put it in context and meaning. The self-driving car will use that information plus traffic flows to say, hey, there's a gridlock up ahead, I might as well ease off. And we've proven so far that self-driving car algorithms working really in the streaming analytics environment will save about 30% of the fuel. So whilst I'm very passionate about driving, and the thought of having a car drive for me can make my blood run cold, I've got to say that for day-to-day driving, I just want to get there safely, and I want to get there at the lowest cost. I think we're going to find that many people's self-driving car mode will actually be selected as the default, because it will save an awful lot of money. Moving into the data warehousing architecture on the bottom right-hand corner, parts 3 and 4 are pretty interesting, because this is where we're going to capture all data to a landing zone. And that's one of the brilliant advantages of Hadoop, in that you can throw pretty well anything at it. I've sat in front of enough data warehousing architects in very large companies and said, if I brought you a CD with data that's worth $10 million to your company, worth to you, and could give it to you for free, what would you do with it? They would put it on their desk. They wouldn't know how to use it, because they don't have the ability to just load up data of any type in a production line environment where people are bringing useful things to them and they're turning it into a business asset. So that's one of the benefits of Hadoop. There are some limitations on that, which is why we put a second box in there around in-memory data warehousing architectures. In our case, we acquired a company called Netezza, but in-memory and particularly FPGA-based technology. This is the thing that allowed us to move from low-resolution TV and DVDs in our homes into Blu-ray and high-definition TV. On a Blu-ray disc, apparently you can get 50 gigabytes of data. That's a lot more than you'd get on a standard 1 gig DVD. So how do we get 50 times the data going through? Well, it was the FPGA. It's a piece of silicon built into a Blu-ray player that you can buy in a supermarket for 30 euros. Not expensive technology to acquire, but we put it in this architecture to put most of the pre-processing right at the source of the data as soon as it lands. Number 5, so this is the application platform. So we favor Eclipse, so it's kind of an industry standard application platform, and many of the types of things being built, visualizations and data discovery are the starting point for this, but ultimately we're moving towards a point where a company will build, BMW is a good example, they built 300 applications in that environment, and those are a bit like an iPhone app, in that they're very useful to some people, people self-select, and if you don't like it, you delete it and move on. So what they're doing is publishing out visualization and business diagnostics applications to their own internal version of the iTunes store. So it has to be at an application platform environment. Finally, 6, data governance and integration. This is my background. This is where it all started, but the whole concept is this whole thing is held together with an integrated metadata library. So all of your existing data warehouse assets, all of your existing applications, operational or warehousing, are tied together with a common metadata library, and that has to be compatible with things like Hadoop and any new technologies that come along. So we're very sort of proud of the effort we're putting in to create this metadata management capability. Once you've got that in place, you can do things like requirements management at a business level and map it into technology quite easily. Good example of that within General Motors was a little project that came up where some analysts were looking at engine fire data. And one rose to the surface in a car called a Silverado, which is about a 5-liter engine pickup truck. And this thing had about 30 instances of engine fires. So it was enough to trigger off some kind of analytics of that. And a common theme was found that the engines were all idling in a very cold temperature. So Alaska, Canada, these sort of places where the vehicle was just idling, should have been switched off, but it wasn't. And the engine caught fire. And in the olden days, that would have meant identifying 30,000 customers, recalling them at a cost of $200 to $300 back to a dealer, and then making some changes to the engine management system. But this is a new world, and in this case, the cars are part of the generation that are connected. So part of the engineering inside the vehicle has a SIM chip, like a mobile phone, but built into the car. And in this case, we did the work to diagnose what the problem was and found that actually the setting that should have kept the cooling fan running was default to switch off when the car was idling, because this 5-liter engine would apparently self-cool itself. Not the case in reality. So a piece of code was cut to change the behavior of the engine management system when the car was idling, and that was downloaded to the SIM chip and significantly through the firewalls into the engine management system. That is a significant change for vehicles where typically they're offline and the engine management system was guarded and locked down. And the only way of getting at it was to take the car into a dealer who plug a serial cable into an OBD port, an onboard diagnostics port. But now that's being connected all the way through the GSM network to allow online software updates. That's a significant change in the industry. It saved a fortune. So let's have a look at this thing. The objectives that were published, 25% to 30%, have been exceeded. The operating cost of a terabyte of data in my large clients is around 100,000 euros per year. And well, as we move that terabyte into a Hadoop cluster, we're finding the operating cost falls from somewhere between 1 and 10,000 euros per year. So it's gone from 100,000 to 10,000. That's a significant change, and this is still an operational database being used for production use in a business. My biggest customer, I think they've got 65 petabytes of operational database. If we can move all of that to Hadoop and keep it working, the savings are phenomenal, a ridiculous amount of money. The business value and the IT project capability are largely achieved through the plumbing of sorting out metadata. Once you've got a good central metadata library and you've got good cheap storage, then you can deliver much more business value because business requirements can be mapped into exploiting the data assets much more quickly. So how do we sort of suggest this is used? You know, first of all, the problem is enterprise architecture staff in most of the companies we engage with aren't familiar with the new technology. It wasn't available when they were at college. So our first problem is educating the market about what's possible. Particularly with new disruptive technologies, and particularly Hadoop. We then look at existing data warehouse architectures, and we kind of rate them and score them. And what we'll do is create maturity models. And for General Motors, we had this vision over the horizon of what it could be like. And because that's kind of over the horizon, no one's going to give us money, or no one's going to spend money on building a system like that. We had to break it into a number of tangible steps. But the concept of these steps is that each step has to make money or save money, and it has to be practical, and it has to preferably be very short and agile. So the barriers to that sort of change are really just in the skills and experience of the IT staff who aren't used to working in this way. So we spend a lot of time on education type work as opposed to just building systems. And part of that is the experimentation capabilities. So just get your hands on. I'm going to show you some examples of what it actually looks like. Once you have got your hands on with the data, you'll begin to see, certainly in my world, which is industrial machines and vehicles particularly, that there are fantastic patterns in data. This example here is for real. So 60 days out, 2 months ahead, we can predict almost perfectly a warranty claim will happen. And that's on a very, very high-tech car, a sample of 619 vehicles. And these are some of the most modern cars in the world. They're incredibly well serviced by hundreds of sensors, 200 sensors actually. But if you take an older vehicle, the bottom half of this slide, that's actually a car that I think was launched in 1986, so much, much older technology. So a greater limitation on the type of fault codes we see in the car, and a much limited sort of OBD model. This is before we standardized on a data model for vehicle data. But we can still get 46 days prediction with 86% accuracy. So think of the change in business model, where at the moment, if your car broke, you've got a nightmare on your hands. You've got to get it fixed, you've got to get recovered, you've got to call a service dealer and find someone who can diagnose the fault, find the parts and get it fixed. And it's always under duress. It's never a happy experience. Imagine the car of the future, which is not actually that far ahead, when they call you and say, look, we can detect some early warning signs here, Mr. Woolfe, please bring your car in, so that way we can keep your car running. Now, working on a project with Mercedes, they've decided that actually the best thing to do would be to do their work between about 11 p.m. at night and 6 o'clock in the morning, because most Mercedes aren't being used during those hours. So why can't we use this data to schedule services that actually fit around the customer? I think that's going to really change everything. The kind of people using data, this is pretty interesting, because I've spoken about this idea of a common central metadata platform and a common platform of data that's in disparate systems. And the people pulling this thing apart are typically data scientists. Paco, for example, using RScript, SPSS, which is perhaps a more graphical business sort of facing application for predictive analytics, all the way through to production BI reports. So this is taking the same data, a 360-degree view of the data, and producing a report that could actually analyze an engine fire and then produce a report of the vehicles affected and the home addresses of the people, the contact details of the people who are likely to need some sort of recall, if it turns into a physical recall, that is. And we've also overlaid that with things like spreadsheets, because as Paco said again, you know, everyone's familiar with spreadsheets. Can we use spreadsheets on this kind of data? Well, yes, we can. And what we're also doing are creating wizards, because none of these things are generally speaking familiar to development staff or enterprise engineering staff, so we have to kind of make it easier for them to work with. Here's an example of what it looks like. There's a spreadsheet, you think? Well, it's actually Hadoop data. And the example here is, let me have a think about this one. This was weblog data. And as you can see with the graphic, what we're doing here is simply sorting and filtering it out to try and find out where it's coming from and what it means. And the first thought was to say, well, what language is it in? So we're filtering, sorting, building a chart, and in this case it shows that the language, there are actually a dozen or so languages being used, but the majority of this data set is in English. So that's a starting point, but then obviously you can start using more advanced visualization techniques, such as this sort of mixture of screenshots from the IBM portfolio, to try and show cause and effect, predictive analytics, graphics, geolocation data, and so on. And I think what we're doing here is having to improve the quality of the visual display, simply because when people are using computers of any kind outside of work, they expect a certain quality and standard. And I think most employees have lagged behind the curve here. So we're trying to catch up, and I think the latest wave of this technology will mean that your iPad experience while you're in the car, looking at the car diagnostics as you're going along, will be pretty slick looking, and it will be very predictive, because we're trying to take patterns in data and predict outcomes from that. There are some other examples here. It wasn't just about General Motors. I think I mentioned the BMW case briefly, but there's another project there where we're taking data from their pre-series cars. So at the moment you can buy a 1 Series, a 3 Series, a 5 Series car, as well you know, but of course for each new generation of car there's a test bed fleet of cars where they're trying out their new ideas. And the data that these test cars generates has always been used to test out and check out whether the car's doing what they expected. And one of the problems here is that they had common components, such as a steering column that would be fitted inside a 1 Series, a 3 Series, a 5 Series, and so on. It's the same steering column, but it's been given a completely different stress and stress workload, because a 4x4 would have a different driving characteristics to a 1 Series sports car, and so on. And the ironing out the anomalies in this data was taking about 3 months. So working with them, putting it all in one place, creating this catalog of hundreds of applications, each built for a certain type of diagnostics, we've accelerated that business process from 3 months to a couple of days. And if you're in the business of creating new cars in this arms race of high-tech cars, that 3-month saving is worth its weight in gold. Fiat have taken a slightly different line on the use of data. They're business success has been through the passion people have for the brand, and particularly the Fiat 500. And we're now getting to the point where the new generation Fiat 500 has been out 3-4 years. So people are beginning to think about renewing their cars. And for Fiat, they've caught a good market. They want to keep it. So analyzing the social media data and the sentiment and the interaction that customers who have those cars have with the company, and then targeting them for refresh, can you buy a new car, and so on, has been particularly effective for Fiat. And they've increased their customer retention from the baseline by 7% further. 7% increase over baseline in customer retention through the use of analytics and data. So it does make a difference. It makes money. In the after-sales area, there was one good example, that I won't name the company, but part of the experimental project we did with Hadoop, in this case, involved grabbing all the data we could, putting it in one place, and seeing if we can use our pattern detecting technology, the Watson probabilistic stuff, to look for problems that we didn't even know were there. And by sheer chance, we identified that a $20 million spend per year was going to, this was a goodwill budget. So if you have a problem with a car and the company doesn't fix it first time round, they might offer you some money as a bit of gesture of goodwill, a compensation if you like. And we found that $20 million per year ended up in the banks of employees. That's an interesting correlation. It was internal fraud. The word had spread that if you use a certain claim code, you could get your car pretty well serviced for free. So identifying $20 million worth of fraud actually paid for a great chunk of the project that was put in for that company. I'll talk about connected vehicle quite a bit already, but good examples I've seen of that one with Peugeot, who are taking sensor data through a dongle, back to through streams, back into Hadoop, and running some analytics on it. They've combined it with the databases on availability of parking spaces and of the location and price of fuel. So you can sit in your car and you can push a button when the little orange light is on saying I'm out of fuel, hopefully before then, and it will give you some data back to say, well, you have a choice of 3 suppliers locally. You can push on that one on the touchscreen TV, and it will push it into your sat-nav system. So we're talking about incredibly complex integration from the data of the location of the vehicle and the customer's preference for something, going through into real-time analytics that decides to call a location query in Hadoop to package up some options that have been statistically worked out to be the best ones for you, and then to send it back down to the customer. And the customer pushes the button and sees the price. It has to be pretty much in real time. Now this is beginning to move into the data privacy world, because not many people want to be tracked wherever they go. Some people don't mind. I'm British, I don't care. But some countries, Germany for example, legislate heavily against that. So new services are being created that now have to be put in place within the legal framework for the control and use of data privacy. So the whole concept of the connected car is fraught with legal issues, and in most of the large programs I'm involved with, there's a lawyer in the team, because we have to work out what we can do as new business models are created. Moving into a manufacturing discussion, done a very interesting project with a company who, well, it's Honda. They're incredibly lean and efficient at their process efficiency. So you really think, well, they can't get much better than that. But there was one particular team of people whose job was to keep the welding robots running. So large trucks full of steel components would arrive just in time. They go straight into the welding shop where these things are fixed together to turn them into body shells, and then they go into dipping and spraying and engine fitting and so on. And the problem here is that these 8 robots, whenever they break, you end up with a couple of problems. One of them is that trucks loads of parts end up queuing outside, and they're wasting money and time. But also the whole assembly line stops. So you end up with this team of people whose job is to keep these robots working 24/7 very efficiently, have a problem, in that they have to identify what the fault is, they have to find the parts, they have to fix it, and they can only use about half of their attention to do that, because the other half of their attention is diverted to answering the phone from senior management who are demanding that they fix the problem because the line has stopped. So what we did was take the data off all of these robots and over a long period of time analyze patterns, and we found some. So the significant numbers here were that 80% of unplanned outages are now predicted with more than 8 hours of time. So this team of staff, who were literally on the front line fighting fires, emotionally as well as trying to keep the robots working, are now able to plan most of their work, and the unplanned outages have gone down to 20% of what they were. That's a significant improvement for what was already a pretty efficient company. So how do you get on and do this stuff? Well, you can access Hadoop. In our case, you can just download it for free and play with it, or you can go onto a cloud system and play with it for free. And I think most companies are beginning to realize that building out sandpit models to explore what it actually does is probably a good idea, a good use of time. It's not actually that intuitive to pick up. So we're doing quite well in terms of providing hands-on training and staff who know how to do it to sit next to people to build out these models. And over a period of time, they then begin to move into pre-production and then enterprise architecture discussions where we move back into IBM's comfort zone. But there's some good stuff online to help you get your head around how this stuff can be adopted. But one of the exercises that I'd really encourage you to do first is to do an informal inventory of your data assets. And this is a pretty good matrix. It's pretty simple to understand. And therefore repeatable. So if you look at the bottom half of this stuff, this is internal data. So what data assets has the company got that you already own? It's inside the company or readily accessible to you. And then maybe sorted out into structured data sources and unstructured. And the red and green is really how easy it is for you to get your hands on. If you look at the external data sources, this is where things like IBM's new project with Twitter would probably sit in the unstructured and external bucket, but we're trying to make that button go green. We're trying to make it very easy to access. So when you then sit in front of a bunch of business people and say, you know, okay, your job is to sell cars, to market cars, or to improve business processes, to save money or whatever, what business problems do you think you can solve if all of those green buttons were in the same place? If it was all in one spreadsheet, if you like, because they need it presented in those terms. And oftentimes use cases and then born out of the discussion that would typically say, yeah, I've been involved in inventory analysis for my whole life and we've analyzed it to death and we can't improve that, but we've never really worked out whether there's a correlation between that and warranty claims. It would be interesting to see whether inventory outages causes downstream problems for customers who then defect to another supplier. But when the data is all in one place, those kind of lines of thought can be brought to life. And that's really where the business case has to be generated before we can actually move on. So this quadrant, I love this. This is a really, really good starting point for a conversation. And the main problem that I see to progress in the big data world in industry is that we go through that exercise and then we find that maybe some of the sensor data coming off machines is literally being disposed of at the end of each day. The engineers who finish their shift, they've done their million-part quota, they shut down the machine and they clear all the data off because that's what they've always done. They had no idea that that data could be correlated later on. So we're going to have to change data handling processes at a business level to capture the stuff that we need. I think that's really all I had to say, but I think there's enough time now to firstly nearly get back on track and to take any questions you've got. Just before I do that, we've written a new book. This was out last week. It's just been published by the team who really are involved in our big data strategy globally. And there's a good business bit at the beginning, lots of anecdotes and stories such as the ones I've run through today, and then a good paragraph or section or two on each of the key fundamental areas of technology that I've explained. So, I mean, you can buy this on our friend's Amazon website, but actually if you can find someone in IBM and ask for it, then we can mail you one. Yeah, so don't hesitate to find me today or find anyone in IBM and we'll make this available. It's a good read, and it's hot.